All right, guys. We spent last time talking about permutations, where if you remember, a permutation is trying to count a large group of items efficiently. Okay, so the idea was if we have, let's say 10 people in this class, and we want to see how they can finish a race, first, second, third, or how they can finish maybe their class average, first, second, and third, because that order is important, because being first place is more important than being second place is more important than being third place, right? So once we recognize that order matters, we can define the scenario as a permutation, okay, which is just stating that it's the math word that we use to say that the structure that we're going to use to count these number of instances is one in which order matters. Order is important, okay? Meaning that first, second, third is different than third, second, first, okay? When we recognize that we use a permutation, right there are the three different most common notations that you'll see using a permutation, okay? They'll say capital P, and then they'll have N, comma R. Well, so N is the number of things that you get to choose from. So if we're taking 10 people and picking out 3 of them, so N would be 10, and the number that we're picking R would be 3, okay? Now, you really can't mess that up, because when we grab our calculator and use our calculator, if I put 3, pick 10, my calculator is going to know that that's impossible to start with a group of 3 and pick 10 out of them. Does that make sense? So it'll spit back that it's undefined or just not something that can be done. What that means is, so what will happen, though, what can be a problem is we mess them up in the formula, okay? So n factorial, okay? So the value that goes in your numerator is how many things you're choosing from, okay? And remember, factorial means that that's going to, if it's 7 factorial, that means 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we'll have that divided by n minus r factorial. So what's going to happen here, let's just say that we go back to the scenario that we wanted to go, give me a moment, this thing. So if we have 10 factorial over, let's say, 3 factorial, okay? What's going to happen, just kind of envision what 3 factorial means. 3 factorial means 3 times 2 times 1, right? Will there be a 3 factorial up top as well? Will there be a 3 times 2 times 1 in that 10? Yeah, so what happens is you can visualize, okay, well, I know that because this is going to be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, because that denominator is 3 factorial, it's 3 times 2 times 1, it can maybe give you a shortcut of realizing those are always going to cancel. And when I say 10 factorial over 3 factorial, because of the cancellation, I can maybe shorten things by saying it's 10 times 9 times 8 times 7 times 6 times 5 times 4. Okay? So if I had like 12 factorial over 8 factorial, everything beyond 8, including 8, is going to cancel, right? So 12 factorial over 8 factorial would be 12 times 11 times 10 times 9. Does that make sense? Okay. Couple different ways that we can do this on a calculator. So if we're using Desmos, I believe you can type in, let's say P, and if I go N being 10 and R being 3, will it do anything? Nope. Okay. So let's see here. If you click this, so some calculators, you'll type it in as P and then kind of like an ordered pair like I just typed in, and it will do the permutation for you here. Looks like we have to go to functions. Go to probably miscellaneous. Don't see it there. Don't see it there. There you go. So we go to stats and NPR down here. Okay, so that's what you got to type in, NPR. So then the N value, so the first number you're going to type in is the N value, and then the next value that you're going to type in is what you're choosing. So if I had 10 objects, and I was choosing them 3 at a time where order was important, there's 720 different ways of doing that, okay? Which, if we think about that, that should be the same thing as 10 factorial divided by n minus r, so it would have been 10 minus 3 factorial. You see that gives me the same thing as 720, right? Okay. Or you could put it as just, obviously 10 minus 3, we all know that's 7, so we do it that way. But what are the values that are going to cancel? If I look at this multiplication, will there be a 7 in this numerator? And there's a 7 in the denominator, right? So they're going to cancel, but everything to the left of 7 will not. So 10 times 9 times 8, there's your 720 that way. Okay? So that's the best way of doing it. Now, if you can remember, so NPR, obviously we go through the functions on our calculator to find that command, but you can type in NPR. You see how it was italicized first? So when it's italicized, it's thinking it's going to be a variable, but once it recognizes that there's a function on the calculator that is that command, it will straighten it up and put it in that font, so then we can type in anything we want. So if I messed it up, if we go 3, 10, okay, so it gives me 0, okay, which, kind of think about that, if I have three people and I want to choose 10 of them, how many different ways can I do that? Can't do it, so 0 ways. Okay, so that's why it's giving you 0 there, and that might be the visual there that you need to realize, or that you see, that would tell you that these two things are probably backwards. Okay, think about this: if I had 3 people to choose 3 of them, how many different ways can I do that? You can actually do it 6 ways. Okay, and then remember, that's because order matters, right? Okay, so if I've got 3 people, let's say we've got, let's see here. Let's say we've got Jake, Brandy, and Clyde, okay? And I want to choose all 3 of them. I can go Jake, Brandy, Clyde. I can go Jake, Clyde, Brandy, okay? I can go Clyde, Brandy, Jake, Clyde, Jake, Brandy, okay? Because remember, this is like first place, second place, third place. So these orderings would be all, if these people are getting awards or medals, they're all getting different awards, different medals. Now, we could go Brandy, Jake, Clyde, or Brandy, Clyde, Jake. So how many different total groups are there? There's 6. Does that make sense? Okay. Now, if order did not matter, and I just want to say I've got 3 people and I want to choose 3 at a time, basically what we'd be saying is that the group of Jake, Brandy, Clyde is exactly the same thing as Brandy, Clyde, Jake. So in a permutation, they get counted individually. They get counted ultimately 1 apiece. But in what we call a combination, we'll actually merge those 6 things and say all 6 of those things say the same thing. Okay? And we'll only count those 6 as a 1. Does that make sense? Okay? And we'll have some calculations that allow us to do that. What we find out is if you are going to have, if you're going to do a permutation, so N choose R, okay, or N permutation R, okay, where equals R, okay, then n factorial is your answer. Okay? Now, let's think about this. If I go, one thing I think we got to pay attention to, and I don't want to prove this with you right now, but if I type in 0 factorial, by definition, 0 factorial is 1. Okay? So think about this. If I go n permutation R, okay, where n and R are the same thing. So let's say, just make it 3 permutation 3. Our formula is n factorial over n minus R factorial. But both of those are 3. So we have 3 factorial over 3 minus 3 factorial. Isn't that 3 factorial over 0 factorial? Which 0 factorial we just seen as being 1. So we have 3 factorial over 1. Well, what's 3 factorial? 3 factorial, 3 was the same thing as n. Okay? So we can go n factorial. So if your n value and your R value are the same exact thing, then your permutation gets a little bit cleaner and you can just take n factorial. Okay? You can let you be a little bit more efficient. You don't need to. You can use the formula directly. It's still going to get you the same spot. Okay. Now what I want to talk about, so that idea about permutations is order is important, order matters. I want to talk about, we can take, and when we do questions like this, our assumption is that we call them strings in like computer programming. It's just a list of characters. Okay. A lot of times in your questions that you're going to get, they're going to say how many different words can be made from these, 5 or 6 letters. But the words don't have to make sense. Okay. So if I look at those down there at the bottom, it says MMMOY. That's a word. Okay. That's what when we're talking about this type of stuff, words do not have to have meaning. They do not have to follow our English language. They are simply a structure of letters. Does that make sense? Okay. So this question says, sometimes we are interested in the permutations of what's called a multi-set. Okay. A multi-set is just a fancy word for saying that you have a list of letters or characters, and that list has repeats in it. Okay. So you can think about maybe, when you write a password. Okay. Sometimes you'll write a password where once you use a letter, you use that letter again, right? Okay. We usually don't say I'm going to use a letter once, and I can only use that letter one time in my password. I can't tell you. So a multi-set is a word like mommy. Okay, because it's got multiple M's in it. Okay, so it says, let's suppose we want to form all possible 5-letter words using the letters mommy. Okay, if we look at this way, okay, so I'm going to look at the word mommy, but I'm going to say that M, this first M, has a subscript of 1. This second M has a subscript of 2. And this third M has a subscript of 3, right? Does that make sense? Okay. So because I put subscripts on them, I'm going to say that M1 is different than M2 is different than M3. Does that make sense? Okay. So if I wanted to figure out how many different permutations I can make, how many different orderings, if I went M1, O, M3, M2, Y, this one is different than that one now. Does that make sense? Is everyone okay with that? Okay. So in my list or quantity at the end, this would be counted once, and this would be counted once. Okay? Does that make sense, everybody? If I gave these identifiers, these subscripts to the letters M. For the same reason, M2O, M1, M3Y. That would get counted once. Okay? So what I've got here is a permutation. N permutation R. Okay? We have 5 letters, and we're going to take all 5 of them at a time. Does that make sense? I want to know how many words is that going to make. Well, that's going to make what we just talked about. If N was equal to R, and that's what we've got here, it's just 5 factorial. So 5 times 4 times 3 times 2 is 120. So there's 120 different ways to organize the letters M1, O, M2, M3, and then Y. Does that make sense? Okay. Now, and I've got a list already written down here, but let's write another one. Okay, so if I look at, let's say the list, let's just spell mommy out. So mommy, I'm going to spell that out 6 times. Okay. So would you guys agree that if this was, let's try to keep this in a kind of logical order here. If this was a 1, this could be 2, and that could be a 3, and we'd have the word mommy, right? But this could be a 1, and then this could be the 3, and then that could be 2, correct? It's a different ordering of the M's, but it still spells the word mommy, right? Okay, so that was starting with M1 as the first M. Let's say that M2 is the first M, and that makes this one or this one 1 and 3, right? If this is the second M, then this could be 3 and this could be 1. That's just flipping these 2 around. So flip that M with that M, and it looks like this. But does that still say mommy? Okay. Now I can start with M3, and this could be M1 and M2, but I could also start with M3, and this be M2, and that be M1. Okay? And each one of those I've started with, if I look at these 2, I started with M1. I look at those 2, I started with M2. And I look at these 2, I started with M3. I have exhausted all the different ways that I can write mommy if these subscripts are 1, 2s, and 3s. Does that make sense? Okay. But if I'm thinking about how many different orderings of the letters M, O, M, M, Y, and I don't care that the first M is the same or is different than the second M, which is the same or is different than the third M, I don't want all 6 of those to show up in that 120. Does that make sense? I only want, because if I take the subscripts away, and this is now just the word, wow, that stinks. Take the subscripts away, and that first one that says mommy is the same as the second one that says mommy, which is the same as the third one that says mommy, same as the fourth, same as the fifth, same as the sixth. Does that make sense? Okay. In this 120, in our 120, these are each individually getting counted. Okay. That makes up 6 of of that 120 over here. We don't want them to be counted 6 times because it's still the same order of letters, M-O-M-M-Y, right? So what we need to do is we need to remove those, okay? We also, so we need to take these 6 that make up this 120 and count them only once, okay? But there is also other orderings like M-M-O-Y, okay? M-M-O-Y, where it goes like 1, 2, 3, maybe 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Those 6 are also inside this 120. But what we want these 6 to only be counted one time, only to contribute one time to our total number. We only want these to contribute one time, okay? So how do I get, any ideas on how I get those things to be condensed into one? What operation could I do that would allow us to, close, no, division, okay? When I divide, so what we're going to do is we're going to divide up, basically what happens here, because when I divide, isn't dividing like clustering things up, grouping things? Like if I take 6 and divide it by 2, does that give me 2 groups of 3? Does that make sense? If I take 15 and divide it by 3, does that give me 5 groups of 3? So I'm clustering things when I do division, okay? And that's really what we've got going on here. We've got clusters of 6 items that we only want to be counted as one. So what happens is that we need to divide out by the repeats, okay? If I think about the repeats, think about that M, okay? There are 3 M's, okay? And if I take 3 of them at a time, that's going to give me 3 times 2 times 1, which is 6. The 6 that we get right there is the demonstration, or it's the actual value of how many of these repeats we are getting if we think about those subscripts of 1, 2, and 3 on the M's. Okay? We want to take those and make them into 1. So the way we do this, okay, in a multi-set, okay, what we do is it says the 6 permutations above come from 3 factorial, and that's due to the 3 M's. So it's thus to make sure that these are only counted once, to make sure those are only counted one time instead of 6. Make sure these are counted one time instead of 6. To make sure that something like OMMY is counted one time instead of 6. Okay? YMOMM, so it's counted one time instead of 6. The way we do that, okay, is that you take your original permutation, which was 5 factorial, and then you're going to divide it by the repeats factorial. Okay, so the initial one was 5 factorial, and now I'm going to divide it by the letters that repeat. So we have M's repeat, so I'll go 3 factorial. So that gives me 720, sorry, not 720, 120. 5 factorial was 120. I'll divide that by 3 factorial, which was 6. So now there's only 20 different ways that you can really organize the letters M-O-M-M-Y to get something new. Does that make sense? Okay, that's called a multi-set. Okay, so let's take the word. What's a word that you guys know that has a lot of repeat letters in it? Mississippi. Exactly what I was thinking. M-I-S-S-I-S-S-I-P-P-I, right? If I asked you to reorganize those, maybe, and I asked you, okay, start reorganizing them and just keep track of the different combinations, or I don't want to say combinations, the different structures of letters that you get, okay? Could I take those two S's and replace those? Could I flip-flop those two groups? And I still get Mississippi, right? So I don't want that to be counted twice. I only want that to be counted once. So that's a problem. Could I flip-flop any of the I's? Yeah. Okay. So what we do, how many letters are in Mississippi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so what we do, and this is what this is saying here, okay, you're going to take the number of objects that you have, so we have 11, we're 11 factorial, and this is because we have to, we're requiring that we use all the letters. Okay, it'd be a little bit different if I say, how many different words, you guys have done this, in maybe games when you were younger, how many different, yeah. So we could do something like that. We can determine what that would be. But we got 11 factorial. We're going to use all the letters, 11 factorial. Now what we're going to do is we're going to divide by repeat. Does M repeat? No. Does I repeat? Yes. How many I's do you have? 4. So you're going to put 4 factorial right there. Okay. Now do S's repeat? How many S's you got? So you put 4 factorial. Okay. Do the P's repeat? So I have 2, right? Okay. So the way that's going to look, and I'm just going to grab Desmos to do this for us, but we'll have 11 factorial divided by 4 factorial times 4 factorial times 2 factorial. Okay. So with the letters MISSIPPI, there are 34,650 ways that you can reorder them to where they spell something different. Does that make sense? Okay. If I just wanted to reorder them and not worry about spelling something different, I would have, how many numbers is that? That's 39,916,800 different ways. But that is saying that MISSISSIPPI, when I flip-flop the 2 S's, that I've got really the same thing, that those two get counted individually in that 39 million number. Does that make sense? Okay. My hopes are you can see there's quite a reduction there in the amount of orderings that can take place when we remove the repeats. So it's called a multi-set. Okay. Does anybody have questions on this? The permutation concept, and we'll talk about combinations tomorrow. This concept is something that it's its own branch of mathematics. Okay. Now it intertwines and relates to everything else, but they get very, 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 very complex, and we're just scratching the surface of the surface of the surface. Okay. But that's the logic of permutations. Is that right? So in your homework, when they ask you first place, second place, third place, when they ask you, president, vice president, secretary, when they ask you to identify your top 3 choices for something, they're eliciting the fact that order is important and order matters, so then you're going to choose a permutation. Tomorrow we'll talk about a combination, and that is when order does not matter. Okay, and we'll talk about the scenarios that's important. Yes? Yeah. Huh? You sure you're not, you didn't days off